All right, let's dive in. Today, we're going to put on our architect hats and really dig into one of the most powerful patterns in AI right now, retrieval-augmented generation, or as you probably know it, RAG. We're going to map out the whole journey, from just a pile of raw data all the way to an AI that gives you real, trustworthy answers. So yeah, let's get building. So here's the big question, right? How do you ground your AI in reality? I mean, large language models are absolutely brilliant, but they kind of live in a bubble. They have no idea about your company's latest internal docs, or today's sales numbers, or what's happening in your support tickets right now. And what's worse, when they don't know something, they have this tendency to just make stuff up. We've all seen it. So the real challenge is, how do we connect them to your private, totally up-to-the-minute data? Well, the solution is this really elegant pattern called RAG. The best way to think about it is like you're building a specialized external brain for your AI. So instead of just relying on its generic pre-trained memory, the AI can now go and query this custom knowledge base, your knowledge base, to find the actual facts it needs before it even starts to generate an answer. That's the key. Okay, so here's our game plan. We'll start with the AI knowledge gap and why RAG is the solution. Then, we'll get into the nitty-gritty of building the knowledge library and retrieving the perfect answer. And we'll wrap up by looking at your architect's toolkit to make it all happen. All right, first up, building the knowledge library. This is phase one, the offline process of prepping all your data. I mean, think about it. Before our AI can answer even one question, we've got to get its data ready. This is that crucial behind-the-scenes phase where we take all that raw info and organize it into something super efficient and searchable. So this whole process really boils down to three key steps. First, we've got to segment documents. This is called chunking, breaking them into smaller, manageable pieces so we can find really precise info. Second, we create what are called vector embeddings. This is just a fancy way of saying we turn those text chunks into numbers, a language computers can actually understand. And finally, step three, we index all of that in a special kind of database called a vector store to make it all instantly searchable. And boom, right out of the gate, you've got your first major decision as an architect. How are you going to chunk your documents? Seriously, how you choose to break this stuff down is a foundational choice. It's going to directly impact the quality of your AI's answers later on. This is a big one. When it comes to chunking, it's all about a trade-off between precision and context. On one hand, you could do fixed-size chunking. It's simple, it's fast, you just chop up your documents every, say, 500 words. The problem? You could easily split a really important concept right across two different chunks. On the other hand, you've got more advanced methods like semantic chunking. This is way smarter. It understands sentence and paragraph structure to keep related ideas together. The results are way more relevant, for sure, but it's also a lot more complex to implement. So it's not just a tech decision, it's a strategic one. Okay, so you've got your chunks. Now what? You have to make them understandable for a computer. And that's exactly where vector embeddings come into play. I love this analogy. Think of them like smart index cards. Because instead of just having a title, these cards actually get the meaning and the context of the text that's on them. They capture that meaning as a big list of numbers. And of course, choosing your embedding model is another huge decision. You've got to think about the domain of your data, right? If you have legal documents, you probably want a model that's been trained on legal text. You also have to balance dimensionality, which is just how much detail you're capturing, against latency or speed. More detail is great, but it can slow things down. And a pro tip, for efficiency, you're definitely going to want to use batching to process everything. So now you've got thousands, maybe even millions of these smart index cards. What do you do with them? You can't just throw them in a pile, right? You need a place to put them, some kind of futuristic filing system that can search them by meaning, not just by keywords. And that, my friends, is exactly what a vector store is. Okay, on to phase two, retrieving the perfect answer. This is the real-time mission to find information. Our library is all built and ready to go. Now, a user asks a question, and that one little query kicks off this high-stakes real-time mission to find the absolute perfect piece of information. And this all happens in the blink of an eye. So here's the play-by-play. A user asks a question. Instantly, that question gets converted into its own vector. Then, the system takes that vector and does a semantic search in the vector store, basically asking, which of my document chunks are closest in meaning to this question? It grabs the most relevant chunks, and that becomes the context. Finally, it hands that context along with the original question over to the LLM, which can now generate a totally grounded, factual answer. Pretty cool, right? But it's not always perfect. There's a catch. Sometimes that initial search can be a little noisy. It might pull up results that are in the right ballpark, but they don't precisely answer the user's question. They're close enough. And let's be honest, for a great user experience, close enough isn't good enough. We need perfect. This is where a fantastic little tool called a re-ranker saves the day. Just think of it like a quality control expert. It takes that initial list of close enough results from the first search and puts them through a second, much more intense round of scrutiny. It resorts everything for maximum relevance, making sure that only the absolute best, most precise information gets passed on to the LLM.
And if you want to get even more advanced, your toolkit has a few more tricks up its sleeve. You can use something called hybrid search, which combines that semantic search with good old-fashioned keyword search to get the best of both worlds. You can also do things like query expansion or decomposition, where you break down really complex questions into smaller, bite-sized ones. And this is where that prep work we did earlier really pays off. You can use metadata, things like timestamps or author tags, to filter your results with surgical precision.
Okay, so you get the theory now, but what do you actually use to build this thing? Let's open up the Architect's Toolkit and look at the services you can pick from to put your RAG pipeline together. You've got a few great options here, and it really depends on what you need. If you want to move fast and you just want a fully managed RAG service, something like Bedrock Knowledge Bases is going to be perfect for quick prototyping. Now, if you're building a huge, super custom deployment, OpenSearch Service is what you want for that massive scale and control. And what if you've already got an app running on a relational database? Well, then you can use something like Aurora with the PG Vector extension to add vector search right into what you already have. Super handy.
And really, that brings us right back to the main goal. At the end of the day, all of these decisions we've talked about, how you chunk, what embedding model you use, your retrieval strategy, the tools you pick, it's all in service of one single thing: architecting a pipeline that gives your foundation model relevant, grounded context. That's how you turn a generalist AI into a true expert on your data.
So, as we wrap this up, if there's one thing to remember, it's this: your AI is only as smart as its library. Every single choice you make, from your chunking strategy all the way to which vector store you pick, is a critical piece of the architecture. So the only real question left is, how are you going to build yours?